everyone, this is the package delivery locker for ME106 final project. Our team members consist of Jason Ho, meher.nagpal, and Emily Wang. 23% of the package receivers in America have their package stolen at some point in 2021 because the homeowners lack a security system. So we proposed that we wanted to make an outdoor package locker system that secures and protects the packages for the homeowners. The locker will receive the deposits and require the homeowners to input a security code for package retrieval whenever they want to pick up their package. Our requirements are to have the locker to securely store a maximum of 12 by 12 by 6-inch packaging box, and after we store the box in the locker, the owner must input the correct passcode with the keypad for retrieval. During this time, if the package is removed before the security code is entered, the buzzer will sound until we input the correct passcode. Our target cost was $400, and our due time was December 1st, 2022. This is the overall system of our mechanical hardware. The two actuators we used are the brush DC motor that was used to rotate the lead screw and the servo motor which was used to rotate the lid. The two sensors we used were the IR sensor, which was used to detect the presence or the lack of presence of the package, and the accelerometer, which was used to detect the angle of the lid to alarm if the lid was open without the passcode.
So aligned with the cat model, on the outside of the box, you see there's a keypad and OLED display, which prompt the user to do whether enter the password or to reset the password. Inside the box, on the picture of the right, you see the system is powered by the power supply, and that will rotate the brush DC motor and the servo motor. The DC motor connects to the lead screw with a coupler, and when it rotates up or down, it will hit the limit switch to stop the flatbed from rotation. And then, as mentioned, we do have the IR sensor on the flatbed to detect the object. The project requirement is to have two different motors or actuator and two sensor. So the first motor we chose is a brush DC motor. This motor can operate from 6 to 24 volt. In our system, we connected to an H bridge. We supplied 8.4 volt to the DC motor. The perspec at 24 volt, it can have 1.5 kilogram centimeter torque and rotate at maximum 113 RPM at the rate of low speed. It has a very relatively low current, but it exceeds the limit of the pico board. So we use it in H bridge to distribute to get the current from this power supply. So it is a gear motor. It has 1 to 84 gear ratio.
So the next component we're going to talk about is the servo motor. And as mentioned before, we use this servo motor to rotate the top lid of our project. Some highlights about this part: it is one of our actuators in our project. The operating voltage range was from around 6 volts to 8.4 volts, and we chose to use the 8.4 volts because we wanted to make sure that our lid can be used at any time without any problem. So we chose this motor specifically because we had to calculate the torque that would be required for this system to work. So we chose this one that can use around 58 to 70 kg centimeters. And we also controlled this motor using PWM on the Pico board. So through the code, we were able to send pulse width signals, and using that, we were able to determine the angle we wanted the lid at. This servo motor also has a free range from 0 to 270 degrees, and we were able to kind of experiment with that through the code to get our lid to open and close. The next part I'm going to be discussing is the sensor. One of the sensors we used is the IR distance sensor for package detection. So this was just mounted right on the side of our flatbed and would go up and down with the flatbed as the project would use the lead screw to lift and have the flatbed go down as well. Operating voltage range was 4.5 to 5.5 volts, so we were able to power it through the Pico. One thing about this is that we also were able to use this and communicate to our Pico within our alarm system. So if there was a package that was taken out of our box, the IR sensor would detect that, and the signal would then go to our siren that we have installed in our project as well. So this is our next sensor that we used. We used the accelerometer to determine the lid angular position. This was also powered by the Pico because the operating range was from 3.3 to 5 volts. And for this, we were able to use ADC GPIO, and that was allowed us to have like a range of what values we were going to get from the accelerometer and into our code. This also helped us within our security system because we knew when the lid was open or closed, and when the lid was open, when the password was not inputted to our system, then we knew that there was someone trying to break in. We did also connect this using the Grove connection, so it did make it a lot easier for us to implement within our system.
Now to open the box.
Enter password to this. So then enter passcode. And passcode correct. It opens so smoothly. Now just press pound to close.
So what I learned from the making of this project was the usage of Raspberry Pi Pico and the Citron R2040 baseboard, the pins and the corresponding actuators and sensors. We got to build a mechatronic system design, and we learned to program in MicroPython, which is very useful.
So one thing I learned doing in this project is to find the proper MOSFET for the application. The MOSFET we use is to ring the alarm, the siren. So when I sourced this MOSFET, I reviewed the output performance curve and understand that at 3.3 volt, it has the sufficient voltage and current can pass through this source and the drain gate terminal. And then the second thing I learned is that how to calculate the required torque to rotate a lead screw with a low. So I applied these two knowledge into this project, and we successfully sound the siren and rotate the flatbed.
So one main thing that I took away from this project was the debugging of our system. There was many parts within the project where we encountered some type of problem, but we weren't exactly sure what the problem was. So I guess the process went that we would go one by one and to see like what parts worked and which ones didn't, and we'd kind of divide up the code just to see how where the problem lied. So I thought that was really interesting and useful, and I feel like we can apply that for future projects as well, that debugging technique. Another thing that I thought was really useful was that I gained better practice on how we can distribute the power efficiently throughout the different parts we had. There were some parts that required a lot more power than what the Pico could supply. Since the Pico can supply up to only 5 volts, and we had to supply the motors a lot more, we were able to distribute the power from the main power supply to these motors. Doing that using the voltage division and using resistors, we were able to kind of separate all that, and still send signals from the Pico as well as power it from an external source. So I thought that was also really interesting.